All right, well, welcome back to Snowmageddon. We haven't had a winter, at least around here, for several years like this, so always fun. All right, if we go into the modules for week 2, crazy. We've only had a couple days of school. In fact, my kids are both out of school today because, well, apparently their K through 12s can't go today. So I want to look at some of the items we have in here, and one of the ones that I want to bring to light is this. Now, weirdly, it doesn't want to open, at least for me today in here, and I opened it then in the external link. And it really is, we've borrowed some content from another book. In the latest edition, they would have to charge you. This is apparently available out there. So there's not a ton of difference. This idea of programming logic. And so as you scroll through this and you read this, one of the things that comes out is, how does our computer work? How do things like your CPU, what is the memory, what is the input and output, and finally that we have to have some kind of a language to communicate with the computer. The computer, at the very lowest form, is really only zeros and ones. How do we communicate with that and create this structure? So they list some of them. So they list Visual Basic, C++, Java. There are well over 600 programming languages right now. But we picked Python because it's very much like an English language. So the higher level languages, more English-like, easier to understand in some ways. They take more processing to convert them, though. But at this point, our processing is pretty well done with our computers. Even the cheapest machine you can buy at this point is sufficient to run really amazing programs. So these programming languages have something called a syntax or a language structure. So one of the areas you're going to see is, hey, I have a syntax error, and you're going to see that pop up. And that means that you violated that structure somehow. And we all have in our, English or other languages, we have that same kind of structure. And when somebody violates that, you'll see that it hiccups us. We don't understand the meaning in some cases. So, a couple of things I wanted to mention in here, because we do talk about computer parts and pieces and things. So, down here, so page whatever this is on here now. I thought we'd show me a page number. Page 4, sorry, right over there on the left. So there's a couple of different ways to transform your programming language into machine code. So there's something called a compiler. In other words, it takes your code that you've written and it looks at it, runs it, and then makes a smaller file that's in machine language or nearly down to those zeros and ones, and so it creates a program that way. The other way is something called an interpreter, and the interpreters run in real time. So it used to be a compiled program was a lot faster. Well, now that our computers are so much faster, the reality is that there's not nearly as much difference in there. So there might be a question about it. So I kind of like these. That's why I put them in a couple of those, these 2 truths and a lie. So make sure you look at those. And then what we're really going to start looking at is, how do we create that algorithm? So before we can do anything else, we have to design our program in terms of what we need it to do. So here we have instructions to make a cake. Well, most of us have probably made a cake out of a mix at some point. So here's our instructions. Get a bowl, stir, add 2 eggs, add a gallon of gasoline, bake at 350 degrees for 45 minutes, add 3 cups of flour. Oh. So there's a couple of things wrong with this. So logically, do we add flour after we bake a cake? No. Do we add gasoline? No, generally not. Although I've tasted some truck stop food that might have been that way. So we have to make sure that we have both a logical error, or we have our logic down pat, and that we don't have any syntax errors. Now, the computer will pop up and tell you, hey, you've got a syntax error, but it's not going to be able to tell if there's a logic error. So one of the statements that I always looked at was garbage in, garbage out. So if we don't put the effort into the front side of this, we're not going to get out what we thought we would. All right. So here we have another example. So what we're going to do is we're going to start with the idea of something called pseudocode. So pseudocode we use all the time to represent what we're going to do, and then we translate that into the, in this case we're going to use Python, but it may be other languages. So here we have a very, very simple thing here. So input. Now, we've all had algebra at some point. My number is just a variable. So in this case, it's a descriptive variable, so we didn't just use x. And then we're going to input a number, okay? And then we have set my answer. So this is equal to my number times 2. So one of the weird things to get used to in almost any programming language is that the equal sign is really an assignment operator, not an equal sign. So what it's really saying is I'm going to take this, my number times 2, and I'm going to shove it into this variable called my answer. And then we output that number in some way. All right. So the other piece is programming is typically a cycle. And if we look at it this way, so here we start at the top. We understand the problem. The problem is we need to make a program that will double a number that you input. So we plan the logic, we write the code, and so this is that machine piece translating that code into either a compiled version or interpreted version. We test our program. Does it work like we expect it to? Put the program into production and then maintain it. So that's the piece that oftentimes gets left out is once we write a program, it doesn't necessarily just end. We typically will need some maintenance and other pieces with it. So here's some logic pieces that I think are kind of interesting. So suppose the director of HR says, we need a list of employees who have been here over 5 years. We want to invite them to a special thank you dinner. Seems simple enough, right? But let's take a look at this. Do we want full-time and part-time? Or just a list of full-time, just a list of part-time? Do you want those people that are on a contract basis or permanent employees? What's the cutoff date of that 5 years? The date of the dinner, some other cutoff date? What about employees who worked for 3 years, took a 2-year absence and went back? So the human resource director must make some more decisions in there. So how do we deal with some of those issues? So that all of this is that idea of documentation. So we have to figure out our business problem. And so in this case, it sounds very simple. Everybody that's been employed 5 years. Well, we need to narrow that down with some specifics. Then we can plan our logic, and we can actually do what we call a desk checking, or we can put some sample problems through there. And then we write the code for whatever language it is we're doing. So I'm going to argue that this idea of translating a problem into our algorithm or our set of steps or our logic is probably the hardest piece that we're going to do. So it's kind of putting us in that brain space of, if you remember those horrible word problems in grade school where the train's going left and the other train's going right, and how far do they get apart from each other and those kinds of things. We have to look at these business cases as that idea of a problem. So sometimes sketching out what my details are, just like we did with word problems, are not a bad way to do it. So although, man, I love my computer and I love to do things on it, I will tell you that the first thing I typically do is I'm using a pen and paper on something, trying to figure out what it is I need to do. So we test our program because if it runs, that doesn't mean it's necessarily all correct yet, because we could have a logical error in there. But if it runs and compiles or interprets, we're getting closer. So we always want to test different programs and different pieces and see if that's actually what we're getting. And then finally we put that into production. Alright, so let's talk about pseudocode. So pseudocode, or false coding, is really our way to write things down, and it doesn't align directly, so it's not one sentence from Python. But if we look at it something like this, so typically, and we also see this if we do this with a flowchart, which is another way to program your logic or look at your logic, but we always do a start and a stop. So each individual module will have a start and a stop. We typically use, and you'll see this with a lot of programming languages also, especially Python in this list, of indents make a really great way to block that out. So from this start to this stop, we can see that all of this is a block, if I could get it to all highlight, that's one block then of code. So it's all at the same level. So input my number, my answer equals my number times 2, output my answer. And then we have a start and a stop. So we always start with that idea of a start and a stop, and we look at those thoughts. So now, do you have to use start, stop, begin, end? It's really the same thing. So there isn't one way to write pseudocode with this exception. There are some basic rules we're going to follow. Things like how we name variables. But if you're working for General Electric and you're in the business analysis position where you're writing the pseudocode that then goes to programmers, they probably have a far stricter interpretation and will give you a set of their rules. I realize I'm making like hand gestures that you aren't able to see, but the other way is that idea of flowcharts. And when I went to college the first time and took a computer class, one of the things we had to buy was a little template that you could draw flowchart stuff in. I'm sure they're still around. I can generally sketch those out, but there's a couple of different symbols we need. So that's my input symbol. Weirdly, it's also my output symbol. So be aware that input and output, and then we just use a rectangle for operations or something that's being processed. So what we'd like to do, so here's the same problem. So we use a connector symbol for start and stop, input my number, here we process it, set my answer equals my number times 2, and then we output an answer. So sometimes they call those terminal symbols. So this is the same way to do that. So when we look at this, one of the things that comes out really quickly is you're like, man, all I want to do in this step is multiply by 2. That's not that hard to do. I could do that. But the best thing we do with our computer is that our computer can do something over and over and over and over again. Whereas we are really bad at doing repetitive tasks. If you ask me to multiply 10,000 numbers, oh my goodness, it's going to take me a while, and I'm going to start, my brain's going to spin off, and at some point I'm going to be, multiplying by 3 instead of 2. So let's look at a couple of ways that can be really, really used. And so one of them we're going to introduce you already to is this idea of a loop. So they show an example here if we could do this program where it asks for a number and you can just keep writing additional steps in it. Well, that's useful, but what I'd rather do is write something called a loop. So a loop allows us to do repetitions. And so this right here has a couple of things that we can think about. So if this program is only going to ever do this idea of inputting my number, multiplying it by 2, and outputting it, this is an interesting way to do it. So there's a problem with this though. There's no way for this to ever stop. So notice we don't have a stop sign. So, if I just had a little kiosk and for whatever reason that's all people wanted to do was multiply by 2, that would be a better way to do it. Here's a key to something called a sentinel value. So a sentinel value allows you to set, so we really do something called an if-then statement, but let's look at it first. So we're going to input a number. What we're asking is that question, is that number that we just put in equal to 0? If it is, our program's going to stop. Now, this is not the best way to do that, and we're going to look at better ways to do it, but would this work? Yeah. It's not necessarily what we're going to call structured, so we'll talk about that as we go. But that sentinel value, a lot of times we do something so it's out of a typical range of numbers so that it's not a value we want to multiply by. So other ways we can do it, there's all different kinds of structures that we could set up. Here they're using something called end of file, another way to tell us that we're doing that. But we're setting up something that says, hey, I'm going to stop this operation. So a couple of other pieces so that we know what we're working in. So the best way, or one way to do it, on every computer out there, there's some version of Notepad. So it's called different things with different languages. But it's a very, very simple text editor. So I can put lines of code in here. So input my value. Notepad is really nice. One of the things about Notepad is that it doesn't add any extraneous materials. The downside is Notepad doesn't have any way to help us with our coding, whereas other tools do. So depending on what my desired result is, I may use Notepad, I may use some other form of text editor. So one of them that we use here and is available in my lab is one called Notepad++. Now, don't panic, you don't have to have this right here. So this is just a program that's in Python, and then we're showing it in this program called Notepad++. Now, I can put the same thing into Notepad, and I can use it to work. Now, what do I get out of this is I get this color coding. I can shrink pieces, so it says, all right, here's a function, so I can make that function disappear so I can look at the mainline code. So that's kind of one of the bigger things. Notice it color codes different pieces. It's really handy for a lot of our programming needs. Now, there's one more I'm going to show you, and that actually comes with Python. So once we've installed Python, and we'll work on that here. So Python installs a piece called idle, which so this is idle, and this is their shell. here's where it gets a little more complicated. So right now this is interactive. So I get to click with there, input my value. Oh, it doesn't like that. Well, we'll have to figure out why and such, but it says syntax error. It's interactive at this stage. To get into the editor for multi-lines, we have to click New File. And of course it's going to open in the other window. Open. Alright, so now, if I put that program in, and notice I've got the scale up, so hopefully you guys can all see that. So now, notice it is color-coded. It doesn't have all the functionality of Notepad++, but it does tell us a few things here. We can see that the green is color-coded here. Functions are both color-coded, and then our comments, which you're going to see are very handy, are also color-coded. So this one comes with Python, and quite honestly, you can do everything in the class in this or in Notepad. It's probably better to start with this one simply because it's less overwhelming. It's got some options, but not a ton. If you notice up top, it does have a run command. So when I click run, I have to save it somewhere. And we'll look at where we want to save it. So in other words, what it went through, this one just did a statistics piece. So it created a list of the items, the mode, the median, and the mean. So kind of handy if you're taking statistics classes. But when it runs, notice it pops it back over to this shell. So then I can go down at the bottom and I can once again go take a look at my code. Alright, so that's probably the one, after we show you how to install Python, I'm going to recommend you use. Notepad++ is great. You may already have used it. If you've taken our web page class, I think Lisa actually uses this in hers. So it does have a lot of advantages, and it's also set up for, it can also do a lot of different languages. So if you want to see some of the programming languages out there, you can just look through here and you can see lists of different types of programming languages. And it is not exclusive. There are hundreds and hundreds of them that aren't listed in here. But they've got some helpful pieces that will help with a lot of your stuff. The other piece I really like is that it numbers my lines for me. And I know that seems silly, but when I have an error, so maybe this doesn't work correctly, I have an error and it's going to point to the line that's causing the syntax error. I can then go look, oh, it's line 64 that it's reporting an error. I will say typically an error occurs above where it says it does, because something is wrong in this line, it's going to cause this one to fail. We'll get to that as we go through there. So this is an IDE for Python. So we've looked at a lot of pieces, so I just want to make sure that you read through that, take a look at it, and kind of understand what we're looking at there. Why is that not popping up? There we go. So this is really what we're doing. Identify, design it, write it, test it, and then document so other people will know what's going on in the future. So I encourage you to go through here and look at the terms. A lot of these terms are possibly new. So an algorithm isn't a scary word. It just means it's your step-by-step operations. You use algorithms all the time. Everything you do in your daily life. When I decide I'm going to go take a car drive, I've created an algorithm in my brain about what I need to do. So some of these you're going to see a lot. Identify, design. So there's different ways to do it. So here we've got a flow chart about going to the movies. Can I go to the movies? Do you have homework? Oh, yes. Can you get it finished in time? Yes. Do you have money? Oh, no. And then it all leads back up to this no. So this may not be the best flowchart in the world, but it gives you that idea of how do we break these down into questions. So debugging, in other words, figuring out what's going on with our program, making sure that runs. So, nope, went to the wrong spot. Sorry about that. Come on. So last week we looked at how do we look at things in terms of God, my brain just completely quit. We look at things on our history and how we advanced here, and so now we're going to look at how we do this process. So a couple of pieces in there. We want to look at our some notes here. So I will say that again, any external links in here. So if that breaks, it's kind of cool to see how there are ways to do that. So again, pseudocode, flowcharts, syntax, all of these pieces, you're going to know these names pretty quickly. So refining your algorithm, in other words, making it better. So if we think about it, and they use toast as an example, if you made toast and it was smoking and burnt and black, well, you would adjust your toaster. You'd go back in and turn that knob to 6 instead of 10 and try it again, right? So it's that idea of we're continually moving around. So looking at the pseudocode, so we're kind of jumping pretty quickly here. So here we're talking about if, then, else statements, and so we'll work on kind of what those are. So here we have a flowchart, and again, you can do this in either flowcharts or pseudocode in most cases. So make sure you've read the do's and don'ts about flowcharts and pseudocodes. There isn't. Oh, apparently, I can't spell problem. Problem solving and tools assignment. Let me edit that right while I'm here. All right, update. All right. So let's take a look at this assignment. I know there's a couple of them. You're going to create a pseudocode, and you can look at it based on your last name. So there's a couple of different ones. There also is the ability to possibly earn some extra credit. So how do we do this if we're going to do the charts on, well, there is this Lucidchart you can get a free copy of, or a eval copy. All right. What do I need to do? So notice that this, I'm using that discussion board as a place to do it, so you have to reply. So if I think about this, let me open that up. So write pseudocode steps to create a hot fudge sundae. Include all the steps. Get the dish, get the scoop, look in the freezer, choose flavor. You should also look in the fridge to see if you are out of whipped cream. Include what happens if you don't have it. All right, and then you're going to copy your pseudocode steps into your discussion board post. Perfect. All right, so that is one of the problems you have this week. There's a couple of others. The programming process one. So this one, read all the directions. All right. Create a presentation, likely, telling your audience, future programming students, about the 5 steps of programming. And again, there's all different kinds of ways to do that. So these should be fairly fairly easily done. We'll go through some of the other values here in just a second. Oh, clicked the wrong one again. All right. So then there are a couple of quizzes. So problem solving and design tools quiz. And again, I don't have a time limit set on this, so there a lot of times we put examples like this. So take a look at the pseudocode below, match the words with their category. All right, instruction, variable, or conditional. So get, display, halt. Are those instructional, variable, or conditionals? Well, it sounds like we're instructing. So you just have to break these down into their, match the flowchart to its purpose. So we know that a diamond is a decision making and branching, and we know that the oval is a terminator, stop and start. So now this one's a little tricky, I will say that. An algorithm and a pseudocode are the same thing. Had I changed that to say they solve the same problems or do the same output, yes, but are they really the same thing? No. All right, so it shouldn't be horrible this week yet. So I want to go back and let's do a pseudocode of something a little different so that we get the idea of what something might look like. So I'm going to open up Notepad. I think I have it big enough to see. Close that. Close idle. There we go. All right. So what I want to do is a different example of so I want to write something about how to order at a pizza place, pizza joint, whatever you want to call it. So I'm going to create a list of steps that I get to that point. So I'm going to walk to the table. Now, I first need to go start. Now, once I did that, then I can indent that so I can say that, hey, that's part of my process. Walk to the table, sit down, wait for menu. So we're waiting for the menu, waiting, so we have a pause feature in there. We're going to read the menu. If pizza good, and notice I'm indenting again, order a so if pizza sounds good, order a cheese pizza. Now I'm going to show you another line we'll use in our programming here. And I'm going to come back out to this same level, else. What else can we typically order at a pizza place? Nothing. Let's imagine they have ham sandwiches. So what we've done here is set it up so that it's just a strange piece of code here, because I'm coming in and saying, well, read the menu. So we're very vague and general in this. Depending on what we're trying to write code for, we may need to be much more specific. So here, I made that assumption that if pizza sounds good, you're going to order a cheese pizza. I didn't give you any other choices in there. So but we certainly could, where you would be able to pick a type of pizza and different things. But it's going to make this a much longer piece of pseudocode. So I could have in here input the name of the waiter. We could do all different kinds of pieces in here. And maybe it would be, before this even, it would become a wait for so we could put in a lot of other details in there. So think about things in your own life. So when we construct a Sunday or whatever the second one was, depending on your last name, we can come up with something like this. So what you're really doing is breaking down what you're going to do in a set of steps that we can then programmatically input later. Alright, so that will be very similar to what you have to do. What I'd like to do really quickly is maybe get us just a little bit ahead. And so to do that, I want to look at python.org. And I want to go through what we need to do to install Python really quickly here. So if I go to python.org, this is again where like the mothership of everything Python. If I go to downloads and it says, hey, I can get Python. Now, it's going to already pick up and say, oh, you must be on a Windows computer. It will do the same if you're on a Mac or other platform. But you can also manually select it if you wanted to download for a Mac, if you have one, or other products. There's lots of other different products they have in there. So other platforms, Windows, Mac, all these different things are there. And it's a fairly small file. Now, you will need administrative rights to run this, and that's where I get hung up here. I know I teach computers, but I don't have admin rights necessarily, so I'm going to see if it'll at least let me update mine. We'll find out. So install now. Oh, maybe it's going to go further than I thought it would. And at some point, it should take a couple of minutes is all to install. It's a pretty lightweight distribution. Wow. All right, so what this will do is when I run idle next time, okay, close. All right, so now if I run IDLE, idle, it's going to appear always in the wrong screen, but so now when I run it, I didn't actually update. So I didn't think it would actually allow it to update, but so what it's telling me here is my version is 3.9.10. It's still going to work for everything that we're going to do. It's just not the latest, greatest update. In fact, you can see that it's from 2022. So you guys will all have information that is actually ahead of mine. All right, so a couple of pseudocode assignments. It's hopefully we're not overwhelming you this first couple weeks. Shouldn't be, I hope. I would rather go slow and steady and launch into how we get there. So again, it's python.org. Back over there. Python.org, download and install. So on almost any version of Windows, Mac, there are even some Chromebook extensions, but I have not tried those, quite frankly. So if you have a Chromebook, and I'm not sure if anybody does, hopefully we're all on Windows or Macs. If you have a Chromebook, you can search for a Python editor in the Chromebook store, the Play Store there also. So they will show you all the different operating systems it can run in. So right now, these are the different releases. So you can see that 9, my version is, it's old. But interestingly, you can go all the way back to almost any version and actually find it. So this is the python.org. This is our mothership. So anytime we have a question about something, this is where we would find the definitive answer. Now, here's what I find sometimes confusing. So documentation, there's all different kinds of things. There is a beginner's guide. So if I click on beginner's guide, it's actually got kind of an interesting tutorials and things, and we're going to use a couple of those. These cheat sheets and all different kinds of things, so are kind of handy to have. So we will try to point out the resources that are good and some that are much easier. So that is what I have for us right now until we start getting a little further in, and then we'll start looking at that. So you have a couple of quizzes and you have a couple of assignments that you need to complete this week. Again, if you want to see the differences in different text editors, if you're on a Mac, there are a lot of text editors for a Mac. I'm not sure about them, but we can certainly look at them kind of together if you have questions or anything. So send email, send text, send hot chocolate because it's cold, and we will get this done. All right. Thanks, everybody.